Thank you, everyone, and welcome to this session. As it said, my name is Marc LeClerc. I'm one of the founders of Noviflow, and today I'm going to be talking about how we help the transition towards a more cloud-centric type of networking, specifically by enabling the network cloud edge. So just a little word about who is Noviflow to start off with. Those of you who have been following SDN for the last few years will know that we've been very active since the beginning in SDN. And we have deployments worldwide by global network operators of our technologies. In fact, you just had a presentation just earlier. For those who were here for John Vestal's presentation, an example of the type of things that people are doing with Noviflow's technology. I'd also like to toot our horn a little bit here by saying that Noviflow was just honored by Intel for being inducted into the Network Builders Winner Circle. And we are also one of the finalists for the Network Transformation Awards. So wish us luck. Hopefully we'll get some good news in regards to the Network Transition Awards as well. Okay. So what is actually fueling the need for a change in networking technology is the whole movement towards cloudification. And if we take a look at the history of it, people had, basically fixed functions, private network functions that were vendor proprietary, fully integrated. It was the whole fixed world. And vendors, to an extent, were happy with that, but customers themselves felt that it was very limiting. It locked them in. And then with virtualization, now we could replace a lot of the proprietary appliances by software that was delivered on standard off-the-shelf hardware, which meant that there was a lot more flexibility in terms of hardware deployments. It also meant that if you had assets, you could redeploy them for other purposes as well. Now, it did have a downside, which led to very, very high server counts, simply because sometimes these functions, particularly networking functions, were rather demanding of the architecture of the chip that was executing them, and so there wasn't a one-to-one translation. You didn't replace one switch by one server. Very often it meant you would replace a switch by multiple servers, and in the case of Noviflow, we have, some of our customers will use one switch to replace 20 or 30 network servers. So there was a cost to virtualization, but the gain was flexibility. Now, with the arrival of cloudification, we hope to gain further benefits in terms of agility of the network, and that's the thing that allows you to say, I'm not going to have to provision for the worst case internally in my network. What happens is that I can depend on resources being available through the cloud so that I can very, very quickly add to my capacity when I need to. So the whole idea was to get to a much more flexible environment, being able to use mixed vendors again, but looking at even the hardware functions themselves as being a service that you can get when you need to and you can scale on demand. Now, that's the objective. The problem is that it's not necessarily easy to get there because networking technologies themselves did not really keep pace with this. So the question becomes, do we have the network that we need? So first off, if we take a look at the technologies, like the ASICs inside of the boxes themselves are fixed functions. Okay, they are not programmable for the most part. And this led to situations where, of course, people wanted to do stuff, and with SDN, we were promising them that they could do these types of things, but the hardware was not delivering. Okay? Another problem was that the incumbent network equipment vendors themselves didn't really have an interest in helping that move along. So we saw the usual, FUD that happened, where essentially people tried to slow things down, well, one of the consequences of that, you saw all of this, first off, this SDN washing, where things that were not SDN were described as SDN, causing a lot of confusion in the marketplace. And if we take a look at it now, I mean, there are people who still are not really sure what SDN is and what it's providing. And even among the analysts, and I speak to most of the analysts, there's certainly a lot of opinions in that regard. And the final point there is from a virtualization perspective, what we have is it provides greater agility, but at the cost of making the network more complex. And it created new challenges as well. So we have essentially an issue where what we want is the ability to program the network really this time, okay? And that requires programmable data planes. Okay, so the idea is we can apply software agility instead of ASICs to be able to have networks that can change and evolve their functionality, to be able to create extensibility of those functionalities via software, to provide open APIs that make it easy to access this functionality and then to integrate it with existing networking environments, and then the ability to repurpose the hardware accordingly so that you're not stuck in a constant cycle of purchasing large-scale hardware. Now, at Noviflow, we're fully convinced that the solution for this, or for a lot of these problems, is to be able to make use of programmable match action pipelines. And I'm not going to go into all of this, into detail, but the basic thing is with a fixed ASIC, since the functionalities themselves are fixed, you create software in your network by saying, well, what can I do? And then you're limited to that. It's really bottom-up type of programming. Okay, so, if the functionality is there to do it, you can take advantage of it, but you can't go beyond that. Whereas with a programmable forwarding plane, what you can do is you can add new functionality to the switch fabric itself. And the result of that is you can go top down. You can take the task that you're trying to do first and then design the forwarding plane that will allow you to deliver that task as efficiently as possible. So the idea very much is to use the match action pipeline then to be able to use software design principles to deliver the functionality in the network. So faster introduction of new network functionality, no forced obsolescence because you can actually repurpose the hardware by adding new software, updating the software. You can also reduce your capital expenditures and OpEx because since you can repurpose the hardware, okay, its lifetime is very much extended. And you can then also, if you're having open interfaces and so on, you can reduce the management costs because the same types of tools that you're using to manage these types of devices and services on, let's say, the compute side, you can reutilize, you can reutilize the same types of strategies and software for the network side. So what impact does this have then on the network as a whole? And the first thing is you want to replace all this specialized middle boxes that are very expensive with something that is fully programmable. And since you're able to use off-the-shelf hardware, white box hardware, you can get economies of scales. You can buy in bulk. You can basically reduce your cost for hardware significantly. You can also offload the control plane processing from the COTS servers. Remember I said one of the problems that happened when people virtualized, they all of a sudden noticed that they had hard limits to scalability. They could go up maybe 10, They could go up, let's say, 10, 15 gig, 20 gig, 30 gig, 40 gig, and all of a sudden it got so expensive to add additional capacity that they couldn't really do it. So first off, this gets rid of all of that. So take the control plane processing, put that on the COTS, take the data plane, put that on something that's more efficient. Leverage a programmable network to offload services as well, servers themselves. Take a look at the functions that are being delivered in network servers and saying, are these some things that might be more efficient running in the data plane itself? Is the network fabric and the networking chips in the network fabric more efficient at doing these tasks? If so, don't do those tasks on virtualized servers. Bring that into the forwarding plane. And then the final point is to accelerate the shift to cloud-native functions. I'm having a real challenge with microphones today. I must apologize. I'm making people smile, though. That's good. At this time of day, yeah, everyone needs a smile, right? So the idea is, if you have a flexible forwarding plane, that makes it easy for you to be able to take services and bring them in from the cloud at need. Then you can do things sort of to be able just to provision to your usual case. You don't need to over-provision. So providing that level of flexibility to make it possible to really take advantage of the cloud to do things like applying, emergency capacity to be able to handle peak loads, or even in unexpected circumstances, so that you can react quickly to changes in network demand. So what Noviflow did is, first we delivered that data plane, and we noticed that it wasn't necessarily the majority of entities on the planet who could actually program that directly. So what we decided to do was to take some of the pain out of doing that by creating an abstraction layer that sits on top of SDN. We call that CyberMapper. And what we're doing there is we're building specialized pipelines that are very efficient at doing particular tasks. And then we expose those functionalities via standard RESTful APIs that make it easy to integrate. So the result is that we can take things like load balancing, as an example, and take that out of the servers and put that directly in the switch. And there are a lot of benefits to doing that, and I'll get into some of this. Okay? And one of the other key advantages is that we're not talking about gigabytes of capacity now. And by the way, one of our customers basically told me the best that he could ever possibly hope out of a standard x86 core is about 2 gig of networking. Not talking other tasks, but general networking tasks. Whereas, as an example, you take one Barefoot Tofino box, or the Intel Barefoot Tofino processor, 6.5 terabits. So a lot of capacity. So this is what it looks like architecturally. Okay, so with CyberMapper, what we did is we took and built all of the stuff that you have in the Threat Intelligence Gateway, and we put that in there. So that means having the ability to do all of the filtering, do the address translation, and the load balancing directly in the switch itself. Okay, so we're calling that the security load balancer. Why? Because this version of CyberMapper, we have optimized the pipeline for security applications. Okay, why is it necessary to state that? Is because if you take a look at security applications and the way you do load balancing, these are specifically stateful activities for the security services, but you want the load balancing, if you put it in the switch, to be stateless, so that you can take advantage of all these techniques to be able to really make the whole environment much more efficient. And you'll see how that happens in a few minutes here. I'll show some examples. The other aspect of doing this is that instead of, here I think I have a laser, instead of having to put a whole bunch of physical load balancers in front of your virtualized devices, and if I can ask a question, an impertinent question here, what's the benefit of putting VMs behind physical load balancers? What have you gained? Okay, which is basically nothing. So the issue is, if you virtualize here, you want to make sure that these links are virtualized. And by putting the load balancing in the switch, it becomes a simple software function. It's provisioning a table inside of this box, which allows us to add and delete devices to this chain. Now, since we're using SDN to do the load balancing, we can also do some special things. So we call this affinity load balancing, where we're able to put large tables in here that control all of the access and do the load balancing, all of the hashing functions to these boxes. And when you add or you subtract a service in here, we do not have to rehash the function. Okay, so in other words, there's never a loss of state that's caused by, let's say, someone adding or deleting a service here. You might lose the state in one server, but the state that was collected for all of the other devices in the chain is preserved. This minimizes the threat from the outside world by maximizing your protection at all times. Now, of course, the security guys really like this. This is taking one of their major headaches, and you move that outside of, let's say, the firewall, and we implement that inside of the switching fabric, and this becomes a transparent function to them. So now these services now become infinitely scalable. And if you saw John Vestal's presentation just previous to this one, one of the things that they've built in the Telstra TPN essentially is kind of an app store where you can have services that you're making available. And if you have this capacity, it becomes very economical. You can build small services or different types of firewalls for different types of customers. You can make them all accessible essentially at the click of a button on a portal. So it all becomes a software functionality. Okay? And then there are expense benefits to doing this. So this is what the network looked like before, okay, or what most people are dealing with now. And the thing is that you have a very, very complex setup here. And since there are all of these hardware connections, taps and so on, all these T's there are network taps, this becomes very difficult to scale. Whereas the solution, when we implement CyberMapper, is that you get essentially this situation here where you have traffic coming in and out, and all of the filtering of the traffic is done in the switch here. So let's say whitelisted traffic, you don't need to send that to these guys, you just send it through. So right off the bat, you're reducing latency on a lot of services. You're also reducing the burden on these boxes. And then the other aspect of it is then you do load balancing in here, so you're able to grow all of these independently, but to be able to do that essentially on demand. So it's a much more flexible situation. And finally, are there any security managers in the room here? Okay, there are none. Oh, okay. Well, I'll throw this out anyway, but by doing this, essentially, you can isolate the management of the security appliances, and you put that in the hands of the security guys, and they don't need to be going back to the network guys every time they need a change done. So it also is enabling the possibility of maybe reducing the human response times in some of these activities. So let's take a look at how this would look like doing that in a network. Okay, so the first stage here, we had some packet brokers here that were going to let's say a DDoS type solution. So we replaced those by putting some of our switches in. So first off, those are now visible in the network all over, so you can make services available on a much broader base. It eliminates the hardware taps, so you can see it's much more simple. And then you can replace the load balancers if it was a tool farm that had load balancers in front. And it also eliminates the single point of failure in some cases where you had these. We basically can create a high availability configuration by using CyberMapper directly. So then let's say we replace the next bunch and the next bunch, and so you end up with what we were talking about earlier, a much more simplified network. And that is the key to making these benefits realizable, because once you simplify the network this way, of course you're reducing your hardware cost, but you're also reducing your operating cost, and you're making the whole situation much more flexible. So you can also do flow-based service chaining, which means that as long as you have the capacity in the switch, you can easily add additional services and make those available. And if you have different customers, you can expose those services in a different order to different customers without having to resort to multiple different hardware chains. So the end result, simplified network, okay? We do all of this in the packet brokering, the load balancing, service chaining, telemetry. We all do that in the switch itself, okay? Now, I'd like to make sure that there's a point here is that this is a programmable environment. That means what we provide inside CyberMapper is not the only thing that you can get. So we can go beyond that and do a lot more additional functionality. Now, we have a a white paper available on the Noviflow website, okay, Security Load Balancer, which goes into a lot more details about how, what some of the challenges are and how we're resolving these challenges with Noviflow. I would invite you to please go and take a look at that when you have a chance. We also have most of Noviflow's executive and key members of our product management at our booth, which is booth A12, A13 on the ground floor. So at the entrance, just to the right after you come in, we invite you to come to our booth and to see a live demo. One of the things that we're showing is using CyberMapper with the Intel Barefoot Tofino processor to do visual latency monitoring. So if you ever wanted to find out how much latency, how much time packets take going through a tool farm, we can tell you with this. So with that, I'd like to thank everyone. And do we have time for questions? We don't have time for questions. Well, you can come down to our booth and you can ask all the questions you like there. There's no time limit in our booth. Okay? Thank you very much. Good day.